Hello, my name is Supaseth Peerawong. So this video I'm gonna do some assignments of digital. So the assignment is recording your presentation in YouTube. So you guys that watching this video, you are watching in YouTube now, and your presentation must contain this topic in English. First one is pre-processing unit, such as wrong switch detector. Start with blank pen paper, then write equation and draw schematic by your hand till finish. Second, state diagram with short explanation. Third one is state table. So again, start with blank pen paper, then write the table by your hand till finish. Fourth one is state assignment, step by step, and write by hand again. And next one is design the middle block by using the flip-flop. Six is synthesis equation of left block that come from state assignment. Step by step again, write by hand again, and also explain how to get this equation. So I think this step is a huge thing of this assignment. And next one is design test vector table. So it's like a clocking table. And the last one is quarter simulation result which uses your test vector. So let's start with pre-processing unit. So start with pre-processing unit, and my last 4 digits of my student ID number is 0235. And if you press any button of this number, you will correct my password, right? And what about the other number? So all switch has about 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And as I told you, if you press 0, 2, 3, and 5, you will correct my password. And what about 1, 4, 6, 7, 8, and 9? So I will separate these two kind of number here. I will write 1, 4, 6, 7, 8, and 9 as a wrong case. And I will talk about the wrong case later. I will talk about the correct password first. So my password has 4 things, right? 0, 2, 3, 5. So I will give the name of each input. It means that I have 4 input, right? 4 password digit. I will give it at W at each input. And I will give it the name. If you press 0, I will give it at W4. 2, I will give it W3. 3, I give W2. And 5, I will give it W1 respectively. And go back to wrong case. Wrong case, right? Wrong case has about 1, 2, 3, 4, 5, 6. It has about 6 things here. And how do I do with this number? So I will write 1, 4, 6, 7, 8, and 9. And this thing, I will call this whole thing as wrong case. Wrong case. So I must combine these all things as the wrong case. And how do I do? I will put OR gate, and I will tell you later why I use OR gate to put these all things. So I need to drawing this Y. Sorry for the rude drawing, but anyway. So I got this as the wrong case. I will give it as input W, but the name is W0 as wrong case. So this is wrong switch detector, right? And the reason that I used the reason that I use OR gate, because if you press this button 1, right, it will be 1 or with anything the output is 1. So if I want wrong case as 1, it mean you do the wrong thing or you press the wrong password. So I want input 1. So OR gate will give the input 1 if you press any button of this kind of this number. So the other example, if I press 7, right, it will be 1 here, and the output also 1, because 1 or with maybe 0, maybe x as don't care term or anything, x is anything, the output is will be 1. So if I want wrong case as 1, I will use OR gate. So now here I have about 5 input, right? So my 5 input is W4 as well, press the 0 button, and W3, W2, W1, press 2, 3, 5 respectively, and the last one is the wrong case. So I must rearrange here. So I put this thing as my input. I call this thing is input. And so it means that I have about 5 input. So how do I represent that I am press 0 button? If I press 0 button, I will give it as 1, 0, 0, 0, 0, right? Because if you put this input together as W4, W3, W2, W1, W0 to analysis, if I want to mean that my 0 button is 1, so the first bit it will be 1, it will be 1, right? So I will write it again as W4, W3, W2, W1, W0 as my input also. And what about W3? W3 it is press 2, right? Press 2 is 0, 1, 0, 0, 0. So this is the second bit of my input, and it high or 1 at the second bit. So it represent that 0, 1, 0, 0, 0 is mean I press 2. And then W3, 0, 0, 1, 0, 0. Press 5 as W1, 0, 0, 0, 1, 0. And the wrong case also, it is 0, 0, 0, 0, 1, right? And maybe it has the other thing, but I will describe you in the part of state assignment. It is not press. So I will show you later at that part. And as I told you, right, 0, 0, 2, 3, 5 is the thing that if you press, my password will be correct. But the order to press, I will describe you in the next part. It is state diagram. And one more thing about this pre-processing unit is about switch. Switch, I use pull down switch, so it is active high. If you press, it will be 1. So this is all about pre-processing unit. Let's go to the next part. So this is my state diagram. As I told you, my password is 0, 2, 3, and 5, and I will divide it into 4 digits. I will represent each digit in the color. First one, 0, I represent to purple. 2, I will represent to blue. 3, I represent to 2, I represent to light blue, and 3, I represent to blue. 5, I represent for green. And before start anything, I will have the rule here. If I write P, it means that it press button. So if I write P complement, it means that it not press button. And P0 it stands for I press on 0. Do the same thing P2, press on 2. P3, press on 3. And P5, press on 5. And wrong here is mean that I press on the wrong button or wrong number of my password. It means that I press on 1, 4, right? 7, 6, 8, 9, so on. So I will start short explanation of this state diagram. Hopefully it's short. First we will start here at the state 0. In the state 0, it will have two situations that make you stay in this state. The first thing is you get the wrong password, so you will go nothing because you got the wrong password. And the second situation, if you do nothing, so it is not press or press bar, press complement. So these two situations all together, it will make you stay in this state. If you want to go to state 1, you must correct the password. How to correct the password? You must press 0, right, to transition into state 1. Now we are state 1. During the clock is running, if your finger is on the 0 button, you will stay in this state in state 1. And if you do the wrong password, got the wrong password, you will go back to state 0. And next one, if you wanna go to state 2, you must leave that digit password. I mean, you must leave the press 0 to go to state 2. And what is the duty of state 2? As I told you, I divided into the 4 digits. These purple things I represent to first digit of my password. So in this whole thing that I'm circling it means that I am in the first digit, right? So if we press 0 and imagine you don't have this state and go to the state 3, it means that you press 0 but you go to the second digit of the password, so it's wrong. That's why we need to have this state. So this state is very important things. And if you want to stay in this state or waiting to go to the state 3 or the next digit of the password, you must do nothing. It's like you press complement. So do this thing to the 2, 3, 5 or light blue, green for the other digits. So you will got this state diagram. And if you can go to state 8, I mean you correct the password 0, 2, 3, 5. The thing that I said it is, if you wanna go back to the state 0 or starting state, you can press any button to go back. So it is press to go back to the state 0. So this is my short explanation of state diagram. So we are now here at state table, and according to my state diagram, it has about 1, 2, 3, 4, 5, 6, 7, 8, and 9 state. 9 state. It means that I need to use 4 flip-flop, because due to the 2 to the power of n, if I just only use 3 flip-flop, I just got only 8 state, but my state diagram has 9 states, so that's why I need to have 4 flip-flop. And 4 flip-flop is about 2 to the power of 4, it equal to 16. That's why in state table we need to have about 16 row. And before anything, first we start with present state. And we have present state, and then we have next state. Present state is mean that you are now here, and next state is mean like a future. If you do something, what is it's gonna happen is next state. And as I told you, it will have about 16 row, right? Because 16 state. So we have S0 state 0, S1, S2, S3, S4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, and then 15. Let's check it about 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. And then we just only use just state 0 to state 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, because our state diagram had about 9 states. So I will divide it state 9 and 2 state 15. I will change the color to maybe red. In state 9 to state 15, we just put don't care term in this table. Just rearrange it. Okay, I will draw the line here to separate these two things. And in next state we have about 6 things. First one is P0. P0 is mean that you place 0 button, and P2 is mean you place 2, P3 press 3, P5 press 5, and wrong case, right? And the last one is P bar. It means that you do nothing or you leave the button. So I just put it P bar. So we have P0 here, P2 is here, P3 is here, and P5 is here, and the wrong things, and P bar or P complement is the same thing. So how to look at the state diagram and change it into state table? First, we just start in state 0. Oh, sorry, I just rearrange it again for easy to check it. Okay. In state 0, the things that make we go to state 1 is press 0, right? So I will write the green color. Green color I just represent to it has transition, and purple I will represent you not have transition. Okay. And other color I just use light blue for represent the things that go but not go forward but go backward, something like this. So I just separate into 3 cases. So let's continue. At state 0, we must press 0 to S1, and then if you press 2, press 3, press 5 or wrong, you will go back. No, sorry, you will not go back, you will stay in state 0, because we are in state 0, and if you do kind of these things, you you will stay in state 0 as I told you. I will use purple things. Sorry, state 0, state 0, state 0, and then state 0. Also the same, if you do nothing or leave the button, you just stay in state 0. So I write here stay forward FW forward and BW represent to backward. So now we are here in state 1. State 1, the things that make you stay is press 0. So I use purple. You must press 0, right? And then if you wanna transition to state 2, you must leave the button. So leave the button, it means that P palm, right? So go forward, transition to state 2. It means you need to leave the button. So this is state 2. And the other things, if you press 2, press T, press 5, or wrong case, you will go back to state 0. So I will use light blue. State 0, state 0, state 0, state 0. Oh, I put the wrong things. It must state 1, right? Stay in state 1. Okay, stay, I use purple. Let's go to state 2. We are now here at state 2. The things that make you stay is leave the button, P complement. So it is S2. And then the thing that makes you transition to state 3, it is press 2, right? Press 2 to go to state 3. And then the other case, you will go back to state 0 because you did the wrong thing. Let me check it. Press 2 to state 3, okay, and then press complement to stay in state 2, okay. We are now here at state 3. State 3, press 2 to stay. Purple, press 2 to stay. S3. And then if we want to transition to state 4, we need to leave the button. Okay, if we leave the button, it will go to state 4. The other case, it is back to state 0. State 4. Stay in state 4, we must press nothing. Stay in state 4. Press nothing. And then if we wanna go to state 5, we need to press 3. We need to press T to go to state 5. Okay, it's forward. Press T, go to state 5. And then the other case is go back to state 0. Let me check. At state 4, leave the button, it means that you stay, and press 3 to go to state 5, correct? We are now at state 5. State 5, the thing that make you stay in state 5 is press 3, right? So P3 in state 5. And then if you wanna go to state 6, you need to leave the button. So it means that leave the button to go to state 6 is forward. I use green color. And other case, blue things, state 0 at P0, P2, P5, and wrong case, state 6. At state 6, if you want to stay in state 6, you need to lift the button and transition to state 7. Press the 5. So press the 5 to go to state 7. Okay, and other case again same thing, state 0, back to state 0, right? Because it's in the wrong case, state 6, wrong case, go back to state 0. So almost done. We are at state 7. If you want to stay in state 7, use the purple thing and you must press 5 to stay in state 7, and we need to lift the button to go to state 8, so we use green things to represent it transition forward. And if you press 0, press 2, press 3 and wrong case, you will go back to state 0. So go backward. I will use light blue, state 0, state 0, state 0, 0. So this thing is represent to the next state. This is a represent the action, what you do. So we are now here at state 8. In state 8, we can see that if you press any button, right? I press 0, press 2, 3, 5, maybe 1, 4, 7. Press any button, you will go to state 0. So it means that if you press this thing, P3, P5, you will go to state 0 also. So it is transition forward. Use green thing. But what if you leave the button? You don't place anything. It will make you stay in state 8. So stay, I use purple, right? In state 8. And state 9 to state 15, we write it in don't care term. I will use brown. So I will represent it as X, don't care term. So I will copy it for faster. Because it is a don't care term, we just put X on it. Here it is state table of the state diagram, 4-digit password. So let's go to state assignment. So we now here at state assignment, and we can write state assignment from state table at left hand side, and state table and state assignment is similar, but state assignment is the converting of the name of the state into the binary number for easy to evaluate into the equation analyzed as an input to our flip-flop. So let's start it. Start, we have present state. Sorry for my rude handwriting, but I need to write fast for don't waste the time. And it's same to state table. We have about 16 state, right? S0 to S15. Sorry, we have 16 states, so we have S0 to S15. It's gonna be 16 state because we use 4 flip-flop, so it is 2 to the power of 4, right? So S0, S1, S2, S3, 4, 5, 6, 7, 8, 9, state 10, state 11, 12, 13, 14, and last one is 15. And then I will draw the line for separate present state and next state. As I told it, similar to state table. And here we have the line. We have P0, P2, P3, P5, and then wrong case. Last one is P prime, right? So I will give the name of the 4 bit of the state. So I just rearrange here, and the name that I will give to the bit of each state. First bit, it is Y3, Y2 as second, Y1, and last one is Y0. So S0, we gonna have 0, 0, 0, 0. S1, we're gonna have 0, 0, 0, 0, 1. S2, we're gonna have 0, 0, 1, 0. It's like a counting of the binary number. So 0, 0, 0, 0 is mean 0, right, in binary. 0, 0, 0, 1 is mean 1. 0, 0, 1, 0 is mean 2. So it's like a counting to 15. And we have 4 bits here. S3 it is 0, 0, 1, 1, right? 1 and 2. It will be 3. S4 is 0, 0, 0. S4 is 0, 1, 0, 0. S5 0, 1, 0, 1. 6 is 0, 1, 1, 0. 7 0, 1, 1, 1. And then last one 1, 0, 0, 0 as state 8. And state 9. State 9, we can see that state table, we don't use it, but it contained in our flip-flop. So I will write it as don't care term. I will give it x, 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 and then copy it until state 15. We put the don't care term. Well, we can see from state table at state 0, if we press 0, it will go to state 1, right? So it transition to state 1, we can see in state diagram. So I describe you in state table part. So we can see that if we press P0, if we press 0, it will go to state 1. And if you do something like a press 2, 3, 5, or did wrong case, or leave the button, it will stay at state 0. So as I told you, state 1, it is 0, 0, 0, 1, right? Come from here, 0, 0, 0, 1. So S1 here, I will write here S1, but in the binary. So it is 0, 0, 0, 1. Then the other term, it is 0, 0, 0, 0. Right? I just look at my state table and then change it into binary. S1 we can see that at P0, it would be the same. It is S1. So it is 0, 0, 0, 1, 0, 0, 0, 1. But if we leave the button, it will transition to S2. So S2 is mean 0, 0, 1, 0, right? 0, 0, 1, 0. So what's my pen? Okay. 0, 0, 0, 1, 0. And then P2 to the wrong case, it will go back to state 0. So it means go back to state 0. Our state 0 is 0, 0, 0, 0. Here, right? So it is 0, 0, 0, 4, 0. Then state 2. State 2, we can see that if we press 2, it will transition to state 3. State 3 is 0, 0, 1, 1. 0, 0, 1, 1. If we press 2, right? 0, 0, 1, 1. Then if we leave the button, it will stay in state 2, which means it is 0, 0, 1, 0. 0, 0, 1, 0. And then other thing is 0, 0, 0, 0. Here is the same. I think I should draw the draw the line for separate these things. Just a moment. Okay, well, we are now here at state 3. State 3, if we press 2, it will stay at state 3, which means it is 0, 0, 1, 1. 0, 0, 1, 1. But if we leave the button, it will go to state 4. State 4 is 0, 1, 0, 0. Here, right? 0, 0, 1, 1. No, 0, 1, 0, 0. Sorry, 0, 1, 0, 0. 0, 1, 0, 0. And then other term, it is 0, 0, 0, 0. Not other term, other things. We can see that at the wrong case here, here, if you do the wrong case, if you did the wrong case, you will go back to state 0, right? So for the faster, I will write 0, 0, 0, 0 at wrong case. Here to state 8, because if you do the wrong thing, you will go back to start state as state 0. So it is 0, 0, 0, 0, 0, 0, 0, 0. Here are the same. Okay, we go back to S4. S4 here. S4. If we press 3, it will go to state 5. If we press 3, it will go to state 5. State 5, it means 0, 1, 0, 1. 0, 1, 0, 1. And then if you leave the button, you will stay in state 4, which means 0, 1, 0, 0. So 0, 0, 0. Because you got the wrong password, you will go back to S0, right? State 0. At state 5, here state 5, we can see that if we press 3 you will stay in state 5. State 5 is 0 1 0 1 0 1 0 1, right? If you press 3 0, and then if you leave the button you will transition to S6, which means 0 1 1 0. Other thing is 0. And then we are now at state 6. At state 6 we can see that if you press 5 you will transition to state 7, which means it is 0 1 1 1. 0 1 1 1 if you press 5, right? 0 1 1 1. And then if you leave the button you will stay in state 6, which means 0 1 1 0. 0 1 1 0. Then 0 0 0. State 7. If you press 5 you will stay in state 7. State 7 is 0 1 1 1. 0 1 1 1. If you leave the button you will go to state 8. 1 0 0 0. And then here are the same. 0 0 0. At state 8 we can see that if you press P0, P2, P3, P5 or wrong case as P1, P4, P7, P9, you will go back to state 0 as reset. So from the state table, if you press any button you will go back to state 0. So it will be 0 at P0, P2, P3, P5 and wrong case, right? 0 0 0. But if you leave the button you will stay in state 8, which means it is 1 0 0 0. So what's gonna happen in state 9 to state 15? I said that it is don't care term, so we just put don't care term in it. So it's like x x x x to state 15, state 9 to state 15. Maybe I should leave it, but I write it. No, I shouldn't. So we'll copy. So we can see that state assignment is just similar to state table, but we just change the S0, S number, Sn something to binary for prepare to evaluate into the equation. So this is state assignment of 4-digit password. So next we're gonna do middle box and we're gonna have equation analyze or synthesis equation. So let's go to the next part. So if we talk about the middle block from the assignment, it says that design the middle block using the flip-flop. So I already drawing the flip-flop and there is many things here, right? The flip-flop, this pin is mean that it contains about the input and clock pin. Clock pin is like a clock pulse and it will check the input when it has the 8 ticker, So this flip-flop is like a active high, and these two pin, it is output pin. This also output pin. But Q prime is like a output complement. I mean, it's like a inverting of the Q, invert output pin. And how do I know that how many I will use flip-flop in my state in my logic diagram? So it depends on my state diagram. As I show you, my state diagram has about 9 states, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the flip-flop required in the n is like if I say that 2 to the power of n is equal to the number of state. So I have 9 state, right? 9 state. So if I use n is equal to 3, it means I said that n is required as a flip-flop. N is 3 is equal to 3 flip-flop. But 2 to the power of 3 is just only equal 8, but I have 9 states, so it's not enough. So flip-flop that I must use in my logic diagram is 16. Sorry, it is 4. N is equal to 4. It means 4 flip-flop. And 2 to the power of 4, right, is equal to 16. So 4 flip-flop can contain 16 states. So I can use 4 flip-flop in my logic diagram. So this is about the middle block. Continue from the middle block. We are now at synthesis equation. So how we can write the equation from the state assignment and how can we get the equation. So first thing, as I told you, we have about 4 flip-flop, right? D3, D2, D1, and D0. And I will give the most significant bit of each button as D3. So this D3, 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 and D2, D1, D0 respectively at each bit. And as I told you from pre-processing unit, I give P0 as W4, W3 as P2, W1 as P3 or press 3, W0 as P5. Oh, sorry, I just confused. W2, this must W2, and W1 as P5, W0 as wrong case, and W4 it is 1 0 0 0 0, right? Because we have about 5 output and this bit is represent we press the button, so it is 1, and then this is 0 1 0 0 0, right? W2 is 0 0 1 0 0, W1 0 0 0 1 0 0, sorry, W0 is 0 0 0 0 and 1, right? And not press it is 0 5 0. Okay, then how we got the equation? So we must look at one because we do minterm. Minterm is SOP, sum of product. It's like A and B, A and B or with C and D, right? SOP. And SOP is midterm, so we must look at one. At D3, so we look at column of D3. Look at one, there is no one, so this 0, 0, 0, 0 here, right? So here it is 1. And how we gonna do next? We look at which row it is. It is state 7, right? And not press like so. We can write P bar and with state 7. So we can write P bar and with state 7. And this one P bar and state 8, right? So it is P bar and state 8. And these two things are together. So we got equation of D3, and we can write more. So P bar here, right? P bar it is not of input. So we must look at 1, right? But this is 0, 0, 0, 0. So how we gonna convert? It means that I must write W4, W3, W2, W1, W0 and complement all, right? Because if I write W4, it means that I press P0, right? But if I write W4 complement, it means that I leave the button P0. So if I write here W4, W3, W2, W1, W0, it means that I leave all the button and wrong case too. So this thing can convert into this thing. And next, sorry, I must, and next, state 7 we can write as we can write represent by y, right? Here y3, y2, y1, y0, but state 7 is 0, 1, 1, 1. We look at 1, but this thing is 0, so how we gonna do? We must put complement to y3, right? Because y3 is 0, so we must put complement to make it 1, because we do midterm y2, y1, y0, and then complement here, right? And then do the same, or this is or, and not P, it is W4, W3, W2, 1, 0, and then complement. Okay, S8 it is 1, 0, 0, 0, right? We must do 1, so y2, y1, y0 we must write complement to got 1, right? Because it is 0, we need 1. So, and with y3, y2, y1 and y0, then complement at y2, y1 and y0. So this is the example of the equation of D3, but for faster I will do this thing before write the equation for easily. Write S0 what we got? S0 we got y3 y2 sorry I must use purple, right? S0 0 0 0 we need 1, so we must complement all things. So it is y3 y2 y1 and then y0 complement. What about S1? S1 0 0 0 1, so we put complement at y3 y2 y1, right? So it is y3 y2 y1 and then y0 we give complement to y3 2 and 1. S2 it is y3 y2 y1 y0 and then complement at y3 y2 and y0, right? 3 2 0 3 2 0. Come on, S3 I must write y3 y2 y1 and y0 for copy for faster. Paste here and state 3, right? We must put complement at y3 y2 because we need 1 but it is 0, so we give complement to it, to this bit y3 and y2. S4 that is y3 y1 y0. We give y3 y3 y1 and y0. Then S5 I must write S5 6 7 8, right? We need 8 state here. Okay, S5 S6 7 8 and then prepare for writing. Okay, S5 0 1 0 1, so we must give the complement at y3 and y1, right? y3 and y1 S6 0 1 1 0 y3 and y0 S7 or state 7 0 1 1 1 0 1 1 1, so we give only at y3. And the last one state 8 1 0 0 0 oh, so we give to y2 y1 and y0. And then we do W things. P0, right? P0. Okay, we continue at D2, so we leave it. D2 we look at 1, right? No one. We found here D2. It is S5 S4 and S5 at P3, so it is P3, right? P3 and with S4 state 4, or with P3 and with state 5. So we find next here, right? So it is P5 and state 6, state 7, P5 and state 6 and state 7. Okay, then no vanity 2 here. Oh, 4 things. Not pressed, state 3 to state 3 to state 6, right? So not pressed and with state 3 or with not pressed and state 4 and so on. So it is until state 6, not pressed and with state 3, not pressed and with state 4, not pressed and with state 5, not pressed and with state 6, right? State 6 is here, state 3 is here, and okay. And these things, or sorry, this thing can convert, right? And or okay. So P3 it is, okay, I must do W, right? We have about 5 W, W4, W3, W2, W1, and W0. W4 it is 1 0 0 0 0, right? W3 is 0 1 0 0 0. W2 is 0 0 1 0 0. W1 0 0 0 1 and 0. W0 1 at the last bit. So W4 we can write as W4, W3, W2, W1, and W0, and we give the complement to W3, 2, 1, and 0, right? Because it is 0 here. We must do 1. So anything is 0, we give the complement to make it 1. Same as W3. W3 is we give complement to W4, 2, 1, and 0, right? W3. So I must write it is place 0, place 2, place 3, place 5, and wrong case for make me not confused. And W2, W4, W3, W2, W1, W0, and I give complement to W4, 3, 1, and 0. P5 is the same. We give complement to 4, 3, 2, and 0, right? And then the last one, we give the complement to, we give bar to W4, W3, W2, W1, and W0, we don't give it. So here we can convert the binary into this variable for connect at flip-flop. And then so we look at our D2. Here it is P3, right? P3 it is this term, so I will copy it. Okay. And with S4 is this thing, right? So we copy and paste. I must use black. So here it is P3 and with S4 we got this. So we do the same. Add another term. P3 and with S5 we look at P3. P3 is this, right? And with S5 is this. S5 is mean state 5. So we write it properly. Okay. Next, it is P5 and with state 6. P5 is this. So I must check it. P5. Okay. State 6. State 6 is here. Oh, sorry. I will check the mark for not forgot it. And then P5 and with state 7. P5 and state 7. Same P5. And with state 7. State 7 is here, right? We check it. Next, not P or P bar and with S3. P bar. Oh, P bar. I forgot it. P bar is mean 0 0 0 0 0 0 0 0 0, right? So it is W4, W3, W2, W1, W0 and all thing complement. So we got P bar as this term, right? And with state 3, here we got it. Copy, paste. We do check mark. Then P bar again. And with state 4. Okay, we check it. Then next term is P bar again and with state 5. P bar. I think we must write here because it's not enough space. And with what? Sorry, I forgot it. and with state 5. Okay, so we check it, and then the last term, right? P bar and with state 6. P bar P bar this thing, copy, and with state 6, right? State 6. So we got the equation of D2, this whole thing, so I will rearrange it, this whole thing, it is the equation of D2. So long, right? I must add page and move this thing because I think it will need more space here, so I will cut it and paste it here. Okay, perfect. Well, we move to D1. So D1, we again, what we gonna do? D1, we look at the things that it is 1 at that bit. So this 0 0 0, so 0 0, here we find 1, and it is P2, right? P2 and with state 2. So we can write P2 and with state 2, P2 and with state 2, or with P2 same, right? But and with state 3. Okay, and with state 3. Then we find D1, no 1. Okay, we find here, it is press 5 and with state 6, 7. So we can write press 5 and with state 6, or with press 5 and with state 7. Next we move to wrong there or 0, and D1 here not press at state 1, state 2. So we or with P bar and with state 1, or with P bar and with state 2. And is there more one? D1 here, okay. D1 here, it is not present state 5, state 6, right? So it is okay, I must write here, not pressed as P bar and with state 5, or with P bar and with state 6. Okay, so we got it, and we can write it in this term, right? This term, so we must write it. So let's do it. P2 and we set state 2, P2. We look at P2. So we copy it. P2 and with state 2. State 2 is here. Okay, check. P2 and with state 3. State 3, right? copy oh I must P2 and with state 3 okay check P5 and with state 6 and then also P5 and with state 7 P5 so it is here and I will copy here because it has 2 P5 and then state 6 state 7 right state 6 and state 7 so state 6 is here then state 7 is here oh state 7 and then and oh I forgot it, this must be or and or here. Okay, we move to not place and with S1 is state 1 not place is here state 1 and together then or we check already. Next is not place and with state 2 not place is mean P bar right and with state 2 we got this thing and together and must be or here we check it already. Next one is P bar and with state 5 P bar okay P bar is here and with state 5 state 5 this state 5 okay and the last term P bar and with state 6 state 6 is here right okay we got all equation oh I forgot or sign okay let's check it 1 2 3 4 5 6 7 8 term 1 2 3 4 5 6 7 8 term okay we got the equation of d1 these whole things of d1 and the last one d0 again we must look at 1 at the column of d0 so there are one here right two place here and here and here and here okay so 1 2 3 4 5 6 7 8 okay d0 start with P0 is mean press 0 and with state 0 must write equal here. It is P0, right? P0 and S0. We look at 1 because we do min term. So it is P0 and with state 0. Next, or with P0 and with S1. Next is or with P2 press 2 and with state 2. Then or with P2 again, but and with state 3. D1, right? We look at this. So it is P3 and with state 4 and state 5. So I write here or P3 and with state 4 or with P3 and with state 5. And then here P5 state 6 state 7. I can write P5 and with state 6 or with P5 and with state 7. So let's check it. 1 2 3 4 5 6 7 8 and check it. I collect all one here at D0. Okay, it must have 8 term. 1 2 3 4 5 6 7 8. Okay, so let's do this thing. P0 it is this one, right? W4 and the other term is complement. I must use black color. And with state 0 is this state 0. Okay, or with P0 again. P0 is this. And with state 1 is here. Okay, then okay, I check it. Check P2 and with state 2. P2 is here. And with state 2, right? State 2. No, there is no space. Okay. P2 and with state 2 is all here. Okay, next is P2 and with state 3. P2 is here, state 3 is here. Okay, check it. P3 and with state 4. Next, P3 is here. And with state 4. Oh, I forgot it again. Or, and with state 4 is Y3 complement, Y2, Y1 complement, and Y0 complement. Copy, paste, and together. Next one is P3 and with state 5. P3. Copy, paste. Oh, I forgot again. P3, okay. I got P3. And with what? State 5. State 5 is here. And okay, we check it. P5 and with state 6. P5 it means page 5 or W1. And with state 6 is here. And check it. And last one is P5, right? P5 is here. And with state 7, right? State 7, this one. Or here and or here. Okay, let's check it again. 1 2 3 4 5 6 7 8. Okay, it must has 8 term. 1 2 3 4 5 6 7 and 8. Okay, then we got the equation of D0, this whole thing. Actually it can derive for short things, but I do the long things for describe to this video. And here is the thing that it must on the it's not in the circuit, or we must connect. So the next part it will be the I think it is okay, design test vector. So let's go to the next part. So this is my test vector table to test in the quadratic prime. So let's start it. First start at clock 1 here. At clock 1 I do nothing, so it's like a p prime or p bar, p complement as well. So it will stay in state 0. Here is state 0. And clock 2 I press 0 or P0, press 0 button here, right? It will transition me to state 1. So state 1 here. And clock 3 I do nothing. So it's like a P prime. So it will bring me exit and transition to state 2. So state 2 is here at the clock 3. Clock 4 I press 2. At clock 4 I press 2, so it bring me to state 3. Clock 5 I do nothing again. So it's like I release the button. So it will bring me transition to state 4. Clock 6 I press 3. So transition me to state 5. Clock 7 do nothing again. Release the button. Bring me to state 6 at clock 7. And clock 8 I press 5 right here. So press 5 will bring me to state 7 at clock 8. And clock 9 I release the button, so it will transition to state 8. So here, right? And then clock 10 I press any button. So I try to press the wrong case too. Wrong case it means it's not 0 2 3 5. So it's like any button like a 1 4 7 maybe 8 9. So at clock 10 I press the wrong case or any button, so it will bring me back to state 0. And then clock 11 I try to release the button or do nothing, so it stay to state 0 again at clock 11, and then clock 12 I try to run it again. So I press 0 here, press 0, it will bring me to state 1, so state 1 is here, right? And then clock 13 is here. I release the button, so it will exit and bring me to state 2. Then clock 14 I press 2 at clock 13 will transition me to state 3. And then here it is, clock 15 I press 2 so press 2 at this clock is mean like a holding the button, so it will make me stay in the state 3 here, right? State 3 at clock 15. Next, if I press clock 6, if I press 0 in clock 16, what it will happen? It will back to state 0, right? Because it's in the condition of the wrong case. And 17, do nothing, stay in state 0 here. And 18, clock 18 I press 0, transition me to state 1. 19, clock 19 release to transition to state 2. And last one, clock 20 I try to press the wrong case, so wrong case is 1 here, so it will bring me back to state 0 again. So here it is an example of test vector table. So let's go into the quarters. So this is my simulation waveform in quarters pan. First, just start at clock 1. Clock 1, you can see that I'm do nothing here, so it will stay in state 0. And then move to clock 2. Clock 2, I put the input as W4. W4 is mean I press 0. So it will bring the state into state 1, state 0 to state 1. So here it is 0, 0, 0, 1, it means state 1. So now it is on state 1. Move to clock 3. Clock 3, I do nothing here. So nothing here will make me transition to state 2, right? State 2. Yes, 0, 0, 1, 0. And next, clock 4. Clock 4, I put the input as W3. And W3 is press 2. It means that you press 2 buttons, so it will make you transition to 0, 0, 1, 1 state, or it is state 4. And next one here, next one, state 5 is here. State 5, I'm do nothing or leave the button, so it will make you transition to 0, 1, 0, 0 or state 4. And next clock, I put the input as W2. W2 is mean you press 3, and it will make you transition to state 5, right? 0, 1, 0, 1. Next one, this clock. At clock 7, you can see that I leave all the button. So it will make you transition to state 6, 1, 1, 1, 0. You can see here 1, 1, 0. So now we are at state 6 and clock 7. So what it will happen in clock 8 if I put the input as W1? And W1 is mean that you press 5. You press button 5, and button 5 will bring you transition to state 7. State 7 is here, 0, 1, 1, 1 is mean you are on state 7. And if I leave the button at next clock, or at clock 9, I leave all the buttons, so you transition to state 8, 1, 0, 0, 0 here, right? And at this state, at clock 10, what I'm do at clock 10. Clock 10 I'm try to press any button, but this case I try to press some kind of wrong password. Wrong password in this case is mean like I pressed 1 4 6 7 8 9 or the number that didn't contain in my password, and therefore in my state diagram I told you that in this state if you put any button you can go back to state 0. So in this case I'm trying to put the input as W0 to show you that any number that can press in this state it will bring you back to state 0. So here it is at clock 10. You can see that if you put the input as here it is a wrong case, so you will go back to state 0 also. And then clock 11 I leave the button, so nothing happened so you are stay in state 0. And then next one, clock 12 I put the input as W4, so it means I press 0. So you can see that it will bring you to state 1 again, 0 0 0 1. And then I leave the button here at clock 13 I leave the button, so it will bring you transition to 0 0 1 0 or state 2. And next one, at this clock it is clock 14. Clock 14 I'm trying to put the inputs at W3 here. It means you press button 2, so you will transition to state 3 1 1, sorry 0 0 1 1. And here it is, I try something. So you can see that next clock at clock 15 I press 2 again. Press 2 again, it will stay in the same state as previous state, so it is state 3, right? 0 0 1 1, it is state 3. And then next one, state 16. State 16 I put the input as W4. W4 it is press 0. So press 0 here will bring you back at state 3 from state 3 to state 2 because you put the wrong thing, you press the wrong thing here. And then next one, state here, right? State 17. At state 17 I leave the button, so it will stay in state 0 again. And then next clock 18. Clock 18 I press 1. Sorry, I press W4. So W4 it means I press 0. It will bring you to state 1. State 1 is 0 0 0 1. And next clock 19 I leave the button. So when I leave the button it will transition to state 2 as shown in the state diagram before. And the last one, clock 20, I'm trying to put the input that is a wrong case. It's like in real situation it's like you press the wrong button, so it will bring you back to state 0. So in this state I put the input as W0. It is like you not press 0 2 3 5, you press 1 4 8 7 9 or some number that not contained in my password. So it's like you did the wrong thing, so it make you go back to state 0. So this is test vector that I'm trying to test in the Quartus Palm.